today we are just going to learn about representing rational numbers on the number line. Okay, we know how to represent natural numbers, whole numbers, integers on the number line. Today we are going to learn how to represent rational numbers. If the number is in the form of p by q, numerator by denominator, how to represent on the number line. The first task is you have to see, okay, whether the given rational number is positive or negative. Okay, first you have to see the p by q is positive rational number or negative rational numbers. If it's having minus, it's a negative rational number. If it's plus, positive rational number. After identifying it's a positive rational numbers, okay, just draw the number line and make center as 0. Positive means you have to take only the right side of 0. Right side of 0, it will be positive. Negative means you go to the left side of 0. Left side of 0, it will be negative. First, you have to check p by q. Rational number is positive or negative. According to that, we have to fix the sign. Then we can just write how to split the number line. So p by q means you have to see the denominator. We have to split q equal parts. According to the denominator, we have to split the equal parts. For example, here 3 by 4 is given. We have to represent 3 by 4 on the number line. 3 by 4 is the positive rational number. So I'm just taking 0 and it's going to be right side of zeros. As the denominator is 4, I'm just dividing as 4 equal parts. After 0, 1, 2, 3, 4 equal parts. Okay, I'm just making as 4 equal parts. Then you can just write it as 3 by 4. 4 is the denominator. Go with 1 by 4, 2 by 4, 3 by 4, and this is nothing but 4 by 4. Okay, 4 by 4, if you just simplifying it, you will be getting 1. We have marked the lines. We have marked the numbers on the number line. So we have to finalize 3 by 4. So now this is our 3 by 4. So now this is our answer, 3 by 4. If it's negative means you have to do it in the left side of zeros. Minus 1 by 4, minus 2 by 4, minus 3 by 4. Okay, minus 4 by 4 is nothing but minus 1 will come. You can just mark it. When we can do this means if it's only one rational number is given means it's very easy. We can just easily mark the number lines on the number line. But here they are given as 2 numbers on the same number line, 3 numbers on the same number lines, right? So we have to practice it. Okay. First you just identify whether it's a positive or negative, then split the number line according to the denominator. Okay. Then you can just easily plot, you can just easily mark the number line. Absolute value of rational number. Okay, absolute value of rational numbers. What is absolute value of rational number of x? Which means, okay, absolute value of rational number, it will be written, okay, inside the 2 lines. So this line is called as modulus. Okay, modulus of x or absolute value of x. So represent its distance from 0 on the number line. So we know distance always it will be positive. It cannot be negative. If you are just taking this 0, the distance between this 0 to 5 by 3 is plus 5 by 3. From this to this side also the distance will be always positive. 5 by 3 only. Then that is same as 5 by 3. Modulus of 5 by 3 is equal to 5 by 3. Modulus of minus 5 by 3 is equal to 5 by 3 plus 5 by 3. You can say absolute value of 5 by 3 is equal to 5 by 3 or modulus of 5 by 3 is equal to 5 by 3. Whatever, if it's positive also positive, negative also positive. Okay, that's one is given. The absolute value of positive number is the number itself. The absolute value of negative number, it's positive value. So negative also will be considered as positive. The symbol, so this one, you can just read it as absolute value of x or modulus of x. The next one is the density of rational numbers. Okay, density of rational number. That means we are going to identify how many rational numbers can be inside any 2 rational numbers. For finding the rational numbers in between any 2 rational numbers, we have 3 methods. One is average method, another one is making the denominator same. By taking the LCM, we'll make the denominator same. That is second method. One is a decimal expansion method. Okay, here I'm just explaining about average method. Okay, for example, if you want to find out the rational numbers between 1 and 3 by 2. 1 and 3 by 2 means, right, we can just add the two numbers and divide by 2. We are getting the answer as 5 by 4. That is nothing but average. Average of these two number will be lies in between the given two rational numbers. Okay, if you are just taking two rational number a and b, which is equal to a plus b by 2, we'll be getting a rational numbers in between a and b. Now here this example, I have taken 1 and 3 by 2. I have to find out the rational numbers in between these two, means just add 1 plus 3 by 2 and divide by 2. You will be getting the average. Center it will come. Again, if I want to find out the rational number between 1 and 5 by 4, add these two numbers, divide by 2. Again, you will be getting one rational numbers. Again, if you are adding these two numbers, divide by 2, you will be getting another rational numbers. Again, if you are adding these two, okay, divide by 2, right? So you just how many times if you want to find out rational number also, we can just find out. That's only we'll be just saying there are infinitely many rational numbers in between given two rational numbers. Okay, keep on finding. We can able to find out the center value, average. Okay, up to many times. Therefore, we can just say there are infinitely many rational numbers between any two rational numbers. Okay, so this is average method. This is the first method, average method we can say. So the next method is, right, making the denominator same. To find n rational numbers between two rational numbers, what you have to do means, so multiply the numerator and denominator by n plus 1. If it's the denominators are same. Okay, if the denominators are same, for finding n rational numbers, you have to multiply and divide with n plus 1. That means the next number. Example, if you want to find out three rational numbers between 1 by 3 and 2 by 3, what I have to do? Here both are having the same denominator. So for finding three rational numbers, I have to multiply with 4, the next number. Multiply with 4 with numerator and denominator, you will be getting exactly three rational numbers. Okay, I'm just explaining here. First, I'm just taking here 1 by 3. 1 by 3. Right? They are asking us to find out three rational numbers. After 1 by 3, directly 2 by 3 is coming. By seeing this, we cannot say there is no rational numbers. The condition is there are infinitely rational numbers. Okay. If they are asking 3 means I can just multiply with 4. If they are asking 50 means I have to multiply with 51. If they are asking 100 means 101. 1000 means 1001. As many numbers if you want, you can just multiply and get it. So 1 by 3, I have to multiply numerator and denominator with 4. Okay, I'll be getting 4 divided by 4, 3 4s are 12. Now, so 2 by 3. So 2 by 3, I have to multiply numerator and denominator with 4. Now I'll be getting 2 4s are 8 divided by 3 4s are 12. Now I can just compare these two. So in between 4 by 12 and 8 by 12, so I'll be getting except 4 by 12 and 8 by 12. So I'll be getting 5 by 12, 5 by 12, 6 by 12, next 7 by 12. So exactly I got three rational numbers. Okay, sometimes in your school they may teach, if the denominators are same, just directly multiply with 10 by 10. So commonly you can go with 10 by 10. So we can just do 10 by 10. You will be getting, suppose in case they are asking find, okay, 12 rational numbers or 11 rational number, means if you are multiplying by 10 by 10, you can get only 9 rational numbers. Okay. So this is the general formula, okay, general method. They are asking three rational numbers, multiply with the next number, n plus 1. So from this, we can just say that there are infinitely many rational numbers between any two rational numbers. They are asking 1000 lakhs rational numbers. I have to just multiply with 1 lakh 1. I will be getting 1 lakh rational numbers. Right. So based on this, right, if they ask us to plot only one rational numbers on the number line, it's very simple. But here, exercise 3.4, question number 1. Represent the rational numbers 2 by 3 minus 5 by 4 and 1 by 2. That is 1.5 on the single number line. Okay, they ask us to mark in this single number line. So two method is there. One is, right, so we have to make the same denominator. Okay, after making the same denominator, right, you can just easily plot the point on the number line. That is one case, right? So that I just quickly explain, but okay, exactly we cannot mark as three numbers are given. Exactly we couldn't able to mark on the number line. Anyway, I'll just explain that method and another method also. Okay. So by making the denominator same means, so first one, what you have to do here? First you have to find out the LCM of 3, 4, and first of all, you just convert fixed fraction into proper fraction. Okay, so we can just keep the 2 as the denominator, just multiply 1 2 are 2, 2 plus 1 is 3, 3 by 2. Right, so now I have to LCM of 3, 4 and 2. Okay, first you have to make the denominator same, so that I have to take the LCM of 3, 4 and 2. Okay, if I just take the LCM 3, 4 and 2, you have to go with the say LCM method. Okay, you will be getting 12 as a LCM. Okay, so you'll be getting 12 as the LCM. Now I can make 2 by 3 with the denominator 12 minus 5 by 4 with the denominator 12, right? So we can just write 2 by 3. So 2 by 3. I just want to make the denominator 12. So 3 4s are 12, 2 4s are 8. So I can just write it as 8 by 12. Now the same minus 5 by 4. Minus 5 by 4, we can just write it as 4 3s are 12. So 3, 5 3s are 15. Okay, minus 15 by 12. Next one, 3 by 2. So 3 by 2. So 3 by 2 means, so 2 into 6. 2 6 are 12. So 3 6 are 18. 18 by 12. I just made all the denominators are same. Okay. Now I can just draw the number line. Okay, this is one of the method. Okay, so I can just draw the number line. After drawing the number line, right, so in the center you can just mark it as 0. Mark center as 0. Right, so in the positive side, we have to go with how to write this. So this should be 1 by 12. Okay, then 2 by 12. Then 3 by 12. So equally how to mark 3 by 12. Up to we have to get 8 by 12 is there. We can just mark this is 8 by 12. Then, okay, after some times you have to mark 18 by 12 also. So you can just use dot and just mark it as 18 by 12. On the left side, you have to get minus 15 by 12. So we can just take this as minus 1 by 12, minus 2 by 12. Okay, so up to, right, so you can just take this as minus 15 by 12. This is one of the method. Okay, we have two methods. This is one of the method by making the denominator same. Okay, here we will not get the accurate answer as they given three numbers in one number line. If it's only one number line, this is very easy. So I'm just taking this is method 2. Okay, now this is going to be method 2. Okay, so to represent a rational numbers 2 by 3 minus 5 by 4 and 1 by 2, that is 1.5 on the single number line, first identify their position, whether it's a positive or negative, where it will lies. So 2 by 3 lies in between 0 and 1. Okay, so, 2 by 3, if you just simplifying, if you are making as a decimal, so it will be lies in between 0 and 1. Minus 5 by 4, okay, if you are, it will be lies in between -2 and -1. So 1 by 2, 1.5 is will be lies in between 1 and 2. Just find the position first. Then, right, so we have discussed, right, how to represent the number line. So 2 by 3 means it's going to be lies in between 0 and 1. So in between 0 and 1, you have to make it as 3 equal parts. 3 equal parts you have to make. Then we can mark 2 by 3. And minus 5 by 4. It will be lies in between minus 2 and minus 1. So use the suitable division. So all the numbers are lies in between minus 2 to 2. So make the number line as from minus 2 to 2. This is our number line. Okay. Minus 5 by 4. Okay. It's going to be lies in between which interval? So minus 1 to minus 2. Okay. First you just mark minus 2, minus 1, 0, 1 and 2. This is a common. Give some gap and mark. Next you have to find out minus 5 by 4. It will be lies in between minus 2 and minus 1. Okay. As the denominator is 4. Okay. Just make it as 4 equal parts. 4 equal parts. We just learned, right? If P by Q means so Q equal parts. Okay. So make it as 4 equal parts. That is 1, 2, 3, 4. Now actually this is minus 1. This will be minus. Okay. Minus 5 by 4. Next one is 2 by 3. Okay. So 2 by 3. We can just mark it as. So 3 equal parts. 1, 2, 3. This is 1 by 3, 2 by 3, 3 by 3. So 2 by 3 we can mark. This is 2 by 3. Next 1.5. 1.5 means it will be exactly equal. So 2 equal parts I go to mix. So this is 1 means 1.5, 2. Question number 2. Find 3 distinct rational numbers that they lie strictly between minus 1 by 2 and 1 by 4. Strictly between means the number should be in between these two. If you can, this also we can go with average method, right? Or we can go with making the denominator same. Okay, average method you may get confused. We can go with LCM method. If they are having the same denominator, as they are asking 3 distinct rational number, we have to multiply with 4. Correct? 3 means you have to multiply with 4. Here the denominators are not same. First step you have to make the denominator same. Then you have to multiply with 4. Okay. So first for making the denominator same, I have to just find the LCM. Okay, LCM of 2, comma 4. Okay, 2, comma 4 LCM it will be 4 is the LCM. Okay, as LCM is 4, I can make minus 1 by 2. Okay, minus 1 by 2, right? So I should make it as a denominator 4. I should multiply with 2. 2 2s are 4, right? The same 2 should be multiplied with numerator. So I'll be getting minus 2 by 4. This will become minus 2 by 4. Next 1 by 4 I can take. So 1 by 4 is already having 4. I should multiply with only 1 into 1. So I'll be getting 1 by 4. Both are having the same denominator now. Minus 2 by 4, 1 by 4. So in between you will be having minus 1 by 4 and 0 by 4. We are having only 2 rational numbers. They are asking 3 rational numbers. As they are asking 3 rational numbers, I have to just multiply with 3 plus 1. That is nothing but 4. I have to just multiply with 4 with numerator and denominator. So therefore, right, so what I have to do? For finding 3 rational numbers, minus 2 by 4, I should multiply with 4 by 4. Okay, 4 by 4. What will I get? Minus 4 2s are 8 by 4 4s are 16. Next one, 1 by 4, I should multiply with 4 by 4. Okay, 1 4s are 4. Divide by 4 4s are 16. Now in between these two, I can just find out, right, as many rational numbers I need. So therefore, I can just write, they are asking only 3 rational numbers. Okay, therefore, 3 rational numbers. Three rational numbers are either, if you want to take only positive means you can go with the positive. What are the numbers? 1 by 16, 2 by 16, 3 by 16. So in between means you should not include these two numbers. Okay, if you want to go with only positive, we can go with positive, or we can go with minus 8 by 16, we should not take. So next one is minus 7 by 16, minus 5 by 16, minus 4 by 16. That also we can write. So I think we can go with only positive, right? So I'm just writing only positive. So 1 by 16, next 2 by 16, next 3 by 16. They ask only 3. So I can just write only 3. Okay, make the denominator same, then multiply with n plus 1. Question number 3, simplify the expression. Minus 1 by 4 plus 5 by 12. Okay, so this is nothing but adding the fraction. Okay, both are having different denominator. So two ways there. One is butterfly method, you can do it. Another way is LCM method. So we can go with LCM method, right? So we can just find out. So LCM of 4 comma 12. First you just take 4, okay, and 12. So we are going to use L method. Okay, so you can just use only the prime numbers. So I can just go with 2 table. So 2 2s are 4, right? Next 2 6 are 12. Next again I can use 2 table. 2 1s are 2, 2 3s are 6. Next I can take only 3 table. 1 means you can write 1, and 1 3s are 3. Okay, that's it. Now therefore the LCM. Therefore, so LCM is equal to 2e into 2e into 3, right? So 2 2s are 4, 4 3s are 12. Okay, therefore the LCM is equal to 12. I have to make minus 1 by 4 with the denominator 12, right? So therefore here I can just write, okay, this side I'm just doing it. Now therefore minus 1 by 4, I have to make the denominator as 4. So 4 into 3. Okay, 4 3s are 12. So the same 3 should be multiplied with numerator. Therefore, minus 3 by 12. The next one is 5 by 12. Okay, 5 by 12 is given. So I have to make the denominator as 12. So already we have 12. So you can just multiply with only 1. Okay, so you'll be getting 5 by 12. Now we can just simplify this. Okay, minus 3 by 12 plus 5 by 12. Okay, so therefore I can just go into minus 3 by 12. Okay, plus 5 by 2. Now both are having the same denominator. Keep the same denominator. Okay, as you have minus, we have to subtract the numerator. Minus 3 plus 5. So minus 3 plus 5 is 2 by 12. So 2 by 12 is nothing but 1 by 6. Okay, 1 by 6 is the answer. Now question number 4. A tailor has 15 3 by 4 meter of fine silk. If making one kurta requires 2 1 by 4 meter of silk, exactly how many kurtas can he make? Okay, total length is given 15 3 by 4. For making one kurta is given 2 2 1 by 4 meter of silks. How many kurtas we can make? First you just write what is given. The total length of fine silk is given 15 is given 15 3 by 4. As is given as a mixed fraction, just convert into improper fraction. Keep the same denominator. Multiply. 15 fours are 60. Okay, 60 plus 3. 60 plus 3, you will be getting 63 by 4. Okay, meter. For length of one kirta, that is also given in mixed fraction. So 2 1 by 4. Just convert into improper fraction. Keep the same denominator. Multiply. 4 2s are 8 plus 1 is equal to 9 by 4. Okay, 9 by 4 meter. They are asking how many kurtas. So number of kurtas is equal to total length of fine silk divided by length of one kurtas. Okay, so length of one kurtas. So total length of fine cloth is given 63 by 4, just divided by length of one kurta is 9 by 4. So we have to divide one fraction by another fraction. So dividing one fraction by another fraction, okay. So take the reciprocal and multiply. Take the reciprocal and multiply, or we can go with KCF method. KCF means what? Keep, change, flip. So keep 63 by 4 as it is, change division into multiplication, and flip 9 by 4, it will become 4 by 9. KCF method. Okay, this you would have learned in fraction. Okay, how to divide one fraction by another fraction. Now we can just simplify it. 1 4s are 4, 1 4s are 4, 1 9s are 9. Okay, 7 9s are 63. So now the answer is 7. So therefore the number of kurtas is equal to 7. So question number 5, right? Just case given, find three rational numbers between 3.1415 and 3.1416. We know that there are infinitely many rational numbers between any two rational numbers, right? So we know that, so 3 point, we can just write 3.1415 can be written as 3.1415. So if we are just taking the 0 after the decimal, there will not be any change. There is no value for 0 after the decimal. Correct? The same wise, I can just write 3.1416. The same thing, I can write it as 3.14160. Now, in between these two, I can just find out many rational numbers. So if you are just taking this 150 means 151, 152, 153. They are asking only three rational numbers. Okay, therefore I can just write three rational numbers. Okay, so three rational numbers. Okay, so we should not include these two numbers. In between means we should not include these. Okay, so don't forget. So the three rational numbers are, I can just take it as 3.14151. Next, 3.14152. 3.14153. They are asking only three. So etc. may come inside. Okay, this only is very easy, right? Question number 6. So can you think of other ways to find rational numbers between any two rational numbers? Okay, so we have just learned few methods, right? They are asking what are any other methods? Okay, yes, there are methods. One is taking average. We just learn average method. Next one is by taking common denominator. So we have to make the denominator same. Then we can find out as many rational numbers we need. Next, third one is by decimal expansion. As he said, right? We can use decimal expansion also. So we have three methods. Okay, fine. So up to this exercise, okay, exercise 3.4 is completed. 3.4 is completed.